Hello everyone. So welcome to the class of text analysis. So as I had said earlier, for any data analysis, be it a quantitative data analysis or a qualitative data analysis, three things are very important. So the first thing is the data itself, right? So as a researcher or as a user of the study, right? You need to have a sufficient quality data with you, right? So good amount of data, sufficient data, and good data basically, right? So the first thing is data. So if you have a quantitative study, for example, you are doing some survey, some observation experiment, or suppose you are doing a text analysis as we are doing it now, you have some documents, some reviews of people, right? Customer reviews, anything for that. The second part of any research is, then after you collect the data, then you pre-process the data or you clean the data, right? So for example, when we were doing quantitative analysis, we are talking about how to check for linearity, normality of the data, then whether the data has got missing values or not. And suppose it is, whether if the data is highly skewed, then you need to make some transformations, right? Same thing applies here also. So if you have got a raw data that you have collected from the social media or any document, right, you have to first clean the data, right? Clean the data, like for example, we did tokenization, we removed hashtags, we removed numbers. So because we are doing a text analysis, numbers make have very little meaning to us, so we don't want that, so we removed it. So such kind of cleaning we did. We went for text pre-processing, and after that we saw in the last class how we had a Excel sheet, right? After we conducted a text pre-processing on Python, right? With the help of Python, we did it, and we had a final TA2, if you remember that TA2. So we had this data set, so which had that processed comments, right? So earlier you had raw comments, then we cleaned the comments, then we had processed comments, right? That means these are the final comments which are going to be further used for analysis. Then the last step in any research is that you finally do the data analysis. So for example, in quantitative data analysis, you are doing regression analysis, you are doing for example, for a factor analysis, cluster analysis, or any mean, median, you are trying to find out descriptive statistics. Here also we have certain techniques, which is like what we do is to, with some objective in mind, we try to draw the emotions of people, we try to cluster the topics into several groups or classify them. So such kind of things are useful for us in the text analysis. So today we will be getting into the same and trying to understand now, as we have seen in the last lecture, that we have pre-processed the data and the final data is there with us. So now from here we will learn the different data analysis techniques that is used for text analysis. Okay, so let's start. The most popular text analysis techniques are basically sentiment analysis, topic modeling, cluster analysis, term frequency analysis, and n-gram analysis. N-gram, if you remember, we had done. So n-gram means n is any number and gram means a word basically. So unigram, bigram, trigram, so it can be n-gram, right? So n-gram analysis. Then name entity recognition. So we can use understand what are the popular names or what are the places which are coming in description or in discussion more often. So that also helps us to understand. Okay. And then part of speech tagging. Part of speech tagging is nothing but where the computer will not, in order to improve the understanding of the computer, the researcher will try to tell the computer the different parts of speech. For example, try to break a sentence into noun, verb, adjective, such that preposition, so that the computer is trained better, the machine is trained better to form better sentences, understand the sentences, and make arrangements. Okay. So these are some of the popular text analysis techniques, right? And today we will start with the first one, the sentiment analysis. Okay. So what is sentiment analysis and why it is so popular? Let's see that. So here we will talk about what is sentiment analysis, what are the types of sentiment analysis, what are the challenges of sentiment analysis, and what are the techniques of sentiment analysis, right? So let's see. What does it say? Sentiment analysis is also known as opinion mining or emotion, right? So as you can understand the word sentiment, what are the sentiments? What is your sentiment? How is your sentiment today? Let's say my sentiment is that I am very happy. I have a very positive sentiment, right? I'm suppose I am not very happy, I am unhappy, so I am having a negative sentiment. Now everything in life has is associated with some kind of sentiment, right? Either the sentiment is positive, or the sentiment is negative, or the sentiment could be neutral. Now how do you so when students are asked, how do you like this teacher's teaching? Some students say extremely good, right? Some students might say extremely bad, we don't like, right? Or extremely or not so bad or bad, whatever, but negative. Somebody will say, it's average, we don't want to make a any remark on that, so it is average, so something like that. So what it says is, as it says, it is the opinion mining or emotion AI. So artificial intelligence, right? Emotional AI, which is the computational process of identifying and categorizing opinion expressed in text to determine the writer's attitude towards a particular topic, product or service. Now for example, when you are asking people, for example, what is you purchased a mobile phone, how did you like the phone? Now when you look at the customer reviews, you will see that people write like, I loved this phone, is one of the best phones that I have, right? Some people say, I loved the phone, but the packaging was bad. Some people say the phone is good, the packaging was also good, but the price was, I think, very high. In comparison, there are other phones in the market which provide similar kind of function, but they are lesser priced. So and some other might also say, I am very unhappy because I feel the price is extremely high for me. So whatever it is, it helps the writers or the consumer's attitude towards a particular topic, a product or service. For example, when we talk about concepts like over tourism, now tourism is good, tourism has got so many benefits for the nation economy and everything, but when it comes to over tourism, people start talking about, over tourism is a cause for natural disasters, is a reason for dirtiness in our society, and there are a lot of social issues that come up. So such kind of things are particular topic when you talk, so you get different kinds of emotions, sentiments, right? So sentiment analysis utilizes natural language processing, text analysis, right, and computational linguistics to extract subjective information from the textual data. So what is the subjective information that you are collecting? So because when you are dealing with quantitative things, you are doing a quantitative information, but here you are talking about a subjective information. So for example, when somebody says, I love my school is a wonderful school, but we don't have a good playground, right? Our teachers are very nice, but the time that is given to play is not good enough. Suppose these are sentences. Now from here we try to understand what is the subjective information, what does the student talk about his school, right? So these are the emotions, as you can see here, right? So these are the different various emotions, right? So somebody is unhappy, smiling, extremely happy, whatever it is, how it is, right? Now what are the real world applications? So you can see, so social media monitoring, now one of the uses. So companies analyze tweets, right, Facebook posts and other social media content to gauge the public opinion about their brands or products. For example, a sudden improvement or sudden surge in negative tweets about a new smartphone model can alert the manufacturer to potential issues. So the manufacturer must have done a pretty good job, but then they realize that something is not good because people are saying, we are not happy, the phone takes a lot of time to switch on, or sometimes I am not very happy with the weight of the phone, or I am not happy with the grip of the phone. So there could be several issues, and the company comes to know about it because this data that is available on the social media, where people are constantly talking to each other, right, it is giving them a lot of good information, right? So that information is helping them now to take a good decision, what should they be doing with the current product, the issues with the product. Similarly, marketing, marketers assess customer sentiments to tailor campaigns and strategies. For example, a company may be thinking of launching its products, right, or creating a new promotional campaign, right? So when you are creating such kind of events or such kind of things, then what happens, it helps you to understand the customer sentiment and adjust your campaigns and strategies. Example, you see, the positive feedback on a promotional event can lead to the replication in other regions. For example, I did a promotional event and let's say I got a very good feedback, right, from my potential customers and my existing customers, then what will happen is I feel that because looking at the success of this, I can maybe try it out in some other regions which are similar to the current one, right. So this way, as a marketer, it will save me from a lot of unnecessary headache, and and create a much streamlined strategy or streamlined approach. Okay. The third is customer service, right, where businesses monitor customer reviews to improve products and services, right. So, for example, consistent complaints about a product feature can prompt you for design modifications, right. Or let us say customer service can be understood also. For example, I have a problem, and let's say the computer the sorry the company's service department is not responding. So I have an issue. I am making complaints on that. So these are issues which the company realizes that it is going to create a very negative impact on in the among the customers about its image. So they will immediately work on it. So here, as you can see in this diagram, right. So 5 key business applications of sentiment analysis. One is social media monitoring. So we did that. So managing and monitoring your business reputation. Now just imagine companies spend millions and millions of rupees to manage their reputation, right. So a one small incident or a few incidents where customers may write negative about you may create a very long lasting adverse effect on the consumer's mind or the reader's mind, others who are potentially reading your tweets or such kind of comments, and they may make a opinion about it, right. So managing your reputation, managing your image is a very important thing, and this comes through sentiment analysis. Now how do people feel about my company, what do people feel about my products and services, are all the things that need to be discussed, right, and understood. Analyzing the market response to a product. So we saw that, right, how do people react to a smartphone, how do people react to a new movie, right, that is launched. So what is the review of the movie, is the movie good? So they say the movie was very good, but it is in the end part it was little boring, it was dragging a lot. So such kind of reviews can be helpful, right. Get to know the voice of your customers. Now what is voice of the customer? Voice of the customer simply means that the you understand what the customer needs. So voice of customer is nothing but what does the customer need. So social media, or from those tweets or the text analysis can help you to understand by researching on a document or several documents or such reviews and all. You can understand what do customers actually look in. Say, right, for example, you might be thinking as a company that the product is the most important thing and price and product are the most important thing, but maybe by understanding the voice of your customer you can learn that not only product and price, but customers, for the customers it is very important that the product should be available nearby or easily available. So those things are very, or they look for a warranty, right, or for a immediate return policy, a very fast return policy. Now those are the things which are very important, and obviously as you are in the market, analyzing the market and your competitors is also a very key important task, which you can do by those text analysis or the you know by doing such kind of text analysis, sentiment analysis, you can understand that. Okay, the whether in the, suppose I am in the same smartphone production category, my well, people talk good about me more or about my competitors. Let's say if people are speaking high about my competitors, then I need to realize that I have to also work upon it so that my reviews are better in the future. Now let's go to the types of sentiment analysis. So what it says? It says that sentiment analysis can be categorized into different types based on the complexity and depth of sentiment detection, right. So what level of complexity you are working with, right, and what do you require, how much do you require. On basis of that, we have 4 types of sentiment analysis. First is binary sentiment analysis, then is multi-class sentiment analysis, fine grained sentiment analysis, and aspect based sentiment analysis. Let us see each one of them, what do they mean actually, right. So the first one, binary sentiment analysis, it classifies text into 2 opposite sentiment categories. Now what are the 2 opposite sentiment categories? Now positive sentiment could be happy, for example negative sentiment could be unhappy, right. Similarly satisfied, dissatisfied, excellent, poor, right. So positive and negative sentiment. So binary sentiment analysis talks about only two opposite sentiment categories, right? Bipolar kind of. So, how it works? The machine learning models or the rule based systems analyze textual data and determine whether the overall sentiment expressed is positive or negative, right? The common classification algorithms include naive Bayes, which is basically nothing but it's a, it follows the Bayes principle, Bayes theorem, and then you have logistic regression. So, logistic regression you must have already, I have taught you in the quantitative analysis part. So, which is nothing where the dependent variable is 0 or 1, right, and your independent variables are in a metric scale. Then you have support vector machines, SVM, and deep learning models like long term short memory or transformers, right. For example, you see here, I love this phone is a positive sentiment, right. This phone is terrible is a negative sentiment. So, such kind of sentiments will be easy to understand, right. So, if you see what it says, now Naive's Bayes is a probabilistic machine learning algorithm, right, based on the Bayes theorem, as I said, and it is widely used for text classification like spam detection, sentiment analysis, document categorization, and medical diagnosis, right. It assumes that the features are independent, which is often not true in the real world scenario, right. So, that is why it is called naive. What is the problem? Why it is called naive? Because the algorithm assumes that the features are independent of each other, and they are not related to each other. But is it true? Is it possible? In social science, you will not see anything grossly independent. They are largely related to each other, right. So, that is why it is called a naive Bayes algorithm, and it performs very well in the text classification, especially spam filtering, whether it is a spam or not a spam, to do a sentiment analysis, positive sentiment, negative sentiment. It handles the missing data well and requires very small training data. That is the advantage. Okay. The applications of the binary, the binary sentiment analysis is like it helps in product review, social media monitoring, and customer feedback. So, as we have said, so it determines whether customers like or dislike a product, identify the public sentiment towards a brand or event, categorizes the responses into positive or negative for better decision making. But there are also some limitations. Now, what are the limitations? It ignores the neutral opinions. So, something may not be good and bad only, it can be in between also, right. So, the neutral opinions are neglected here. So, which may contain very valuable information, and it can struggle with sarcasm and irony. Example, you see, oh great, my phone just broke again. So, this is a sarcasm, right. Oh great, my phone broke again. So, it is a sarcasm, you are criticizing. It might be negative, but because the word great is there, it might be considered positive. So, this is the limitation of this system, right. Then you have multi-class sentiment analysis, right. So, multi-class sentiment analysis classifies the text into 3 or more sentiment categories, which was not there in the binary. So, you now have positive, neutral, and then negative. Okay. In some cases, more nuanced classes like very positive, slightly positive, neutral, slightly negative, very negative may be used. For example, in a Likert scale, right, when you are doing a Likert scale. So, you can understand that it can have several levels. Okay. So, how it works? Now, supervised learning models like random forest, gradient boosting, neural networks, or deep learning models analyze the patterns in the text to assign a sentiment category. You see the average example, the food was average, I have had better. Now, what it is saying? The food was average, I have had better is a neutral sentiment. The customer service was outstanding, positive sentiment. I had to wait an hour for my order is a negative sentiment. So, the multi-class sentiment analysis helps you to do this, right. Now, what is the benefit is that the data that is picked up is it can be either a unlabeled data or a labeled data, because suppose for example, what does it mean? Unlabeled data contains only input features without corresponding output labels, right. The model must discover patterns on its own, right. So, this is largely used for unsupervised learning like clustering and pattern discovery. So, what does it mean? Let us understand it more clearly. Unlabeled means where the machine is not told what it is, right, and the machine will try to figure out on its own ki what is this data, right. For example, let us say you put the picture of a tiger and write a tiger, this is a tiger. You put a lion and say this is a lion, and then you show a dog and then you write it is a dog. So, when you are writing tiger and then you are telling the machine this is a tiger. So, this is a labeled data, right. That means the machine will understand, okay, oh, these are the features and this is a tiger, this is the feature, this is a lion, this is the feature, this is a dog. So, the machine is trained now better, right. It is a labeled data. So, labeled data consists of input features and their corresponding correct output labels. So, what is this? What is the product or what is the thing that you are seeing in the image? Now, this is a tiger. Okay. Each data point is explicitly categorized and it is used in supervised learning, right. So, it is earlier one was for unlabeled data was used for unsupervised learning like clustering and pattern discovery. So, where you only had to classify them into different categories. Okay. Here, but as it is saying, it is used for classification and regression. So, for any prediction or to forecast into the future. So, the labeled data will be of more useful because it gives you a supervised learning, right. So, helps the model learn a direct mapping from inputs to outputs. This part is important for you to understand what is a labeled data, what is an unlabeled data, right. Okay. So, what are the applications of the multi sentiment analysis? Now, for example, applications are news sentiment analysis. Now, it classifies news articles into neutral, positive or negative sentiment. Customer service feedback, categorize feedback into more than just positive or negative. Again, it could be a negative feedback, positive feedback, or neutral feedback. Political sentiments, identifying varied degrees of support for the or the opposition towards the leaders, political parties or the leaders, right. But what are the limitations? Does it have limitations? No, yes, it has some limitations. Neutral sentiment can be ambiguous and difficult to classify. Obviously, because it is very difficult. You are not doing it with through a number. You are telling the machine to understand on its own, or you are training the machine. So, how would you train the machine on something which is neutral? Positive words, for example, oh, it's positive, great, good, it will understand. You can tell that. But how will it understand sarcasm? How will it understand a neutral sentiment? That's the limitation. So, it requires more labeled data. So, to improve the understanding, it requires more labeled data to train multi-class models compared to the binary classification. In binary classification, we said no, you need a small training data, that will be good enough because it can understand, the machine can easily understand good, bad, opposites, right, excellent, poor. But here, how will the machine understand that it is a neutral statement and not a negative or a positive statement? So, to improve the accuracy of your model, right, the more you train it, it is better. So, that is why labeled data has to be given as much as possible, so that the machine can create a very trained algorithm and understand more refinedly, in a refined manner, that whether this is a positive, negative or a neutral statement. Then you have fine grained and sentiment analysis. Now, what does it say? This third one, fine grained sentiment analysis, provides a more detailed sentiment score by using a sentiment scale such as 1 to 5 stars. So, for example, very negative -2, negative -1, neutral 0, positive +1 and very positive +2. So, how it works? The sentiment scores are assigned based on the word choice, right. So, intensity and the contextual meaning. So, the machine learning models are trained on the labeled data sets. For example, the data set you find on the Amazon or any reviews, right. So, it by using those labeled data sets, it predicts a sentiment score rather than just a category. So, it gives you a sentiment score. Now, the score is important, right. For example, in your exam, you scored 90% or 90 marks. Now, that is scores is better than saying that you are only a first class, right. So, somebody can say that you are 90%, your friend is 85% and both are first class, but don't you think that when somebody tells you that 90 and 85, it is giving you more clarity? Same thing. So, example, you see, this movie was amazing. This movie was amazing. One of the best I have seen. 5 stars. Very positive. Okay. The movie was okay, but not as great as expected. 3 stars. Neutral or mixed sentiment. Terrible experience. Would not recommend. 1 star. Very negative. So, using such kind of labeled data sets, the machine is trained better to give you a better output. Okay. Applications are, for example, online reviews, social media analysis and survey analysis. Now, for example, it helps companies to understand not just if feedback is positive or negative, but how strong the sentiment is. Let us say the sentiment is extremely negative. So, the company, if it would not have understood, then they would have said, oh, it is negative, it is not in the negative category. But suppose it is extremely negative, it gets a very low score, then it is a real challenge for them to work on it, right. So, they have to maybe expedite the entire process, they have to be very fast so that they can correct the problems. Okay. Similarly, assigns a sentiment score to brand emotions, okay, in the social media analysis, and in survey analysis it converts the customer ratings into actionable insights. Okay. Now, what are the limitations? More complex than binary or multi-class classification. So, it is more complex now, this fine grained one is more complex than the binary and multi-class, right, and it requires more high labeled data to achieve accuracy, right, and scores can be subjective and vary by individual opinion. So, the simple thing is a machine does not understand anything, right. So, the more you train the machine, the more you give more data sets, right, so the machine through its experience will create better and better algorithm, will become more powerful, and the accuracy level of the models will improve. Okay. So, that is what we have to do. The fourth kind of sentiment analysis is called aspect based sentiment analysis. Now, aspect based sentiment analysis identifies sentiments towards specific aspects, features or attributes of a product or service rather than the overall sentiment. Now, many a times we may be more interested to look at the particular aspect. Now, for example, a product, for example, from a marketing mix point of view, we may think of from the product, price, place or promotion point of view, right. So, the marketer wants to know whether the product, what is the aspect, what is the opinion about people on the product or on the price or on the distribution or on the, let us say, promotion. Now, this is done through this aspect based sentiment analysis. So, how it works? The text is first broken down into different aspects, so different topics or features. The sentiment classification is applied separately to each aspect, and deep learning models such as BERT based transformers are often used for this type of analysis. Now, let us see this example. The battery life is great. This is a review which says the battery life is great, but the camera is mediocre. What is saying? The battery life is great, but the camera is mediocre. So, battery life has got a positive statement, camera has got a negative statement, right. The hotel location was perfect, but the rooms were noisy and unclean. Okay. So, location is a positive sentiment and rooms have got a negative sentiment. So, the marketer can look at the different aspects where the positive is and where the negative is, and accordingly they can utilize the resources in a much refined manner, so that with lesser efforts they can get better results. Okay. Applications. Now, the product reviews helps companies understand which specific features, right, customers love or dislike. Similarly, for example, restaurant reviews identify sentiments about the food quality, service, ambience, etc. And in marketing research, analyzes the public sentiment towards various aspects of a product before launching improvements. What are the limitations of this? Now, the limitations is that it requires advanced NLP techniques to detect aspects correctly. Now, you are making it more and more, deep, right. You are taking it more and more deep. First, you started with only binary, then multi class, then you said about fine grain, now you are talking about aspect, each aspect. So, you are subdividing into several, like a decision tree, you are dividing it further and further, right, to get more accuracy. The contextual meaning can be complex. Example, the battery lasts forever, but I wish the charging was faster. Now, is the sentiment towards battery life positive or negative? Now, this is something very tricky. Even a human mind sometimes can go, can misunderstand. So, how about how does a machine then understand? If humans first of all will not realize it perfectly or cannot understand well, how can a machine understand it, right? So, the training has to be on a very high level, right? So, this is the some of the challenges. Okay. If you compare the sentiment analysis types, so this is how it looks like. So, type, sentiment categories, example, and the best used for. So, binary sentiment analysis categories are positive and negative. Example, I love this movie, which is a positive sentiment, and the best used for is basic classification of reviews, social media monitoring. Multi-class sentiment analysis gives you a positive, negative or neutral, right, or more even. The product is okay but could be better is a neutral statement. Best used for news articles, customer service feedback. Fine grained sentiment analysis, it is scale based, example 1 to 5 stars for example. The food was good but not great, so gets a 3 star. So, used for product reviews, customer satisfaction surveys, right. And the fourth one, aspect based, is a sentiment towards specific aspects. For example, the screen is bright but the battery drains fast. Okay. So, it identifies the pros and cons in the product reviews, right. So, these are some of the comparisons of the sentiment analysis types. So, the challenges, now let us look at some of the challenges in the sentiment analysis. So, the challenges make it difficult to achieve higher accuracy. So, you see these are all algorithms which are built to improve the accuracy. So, instead of humans doing a work, because the data size could be extremely large and human minds cannot work. So, you are training a machine to do that, understand it for your benefit, so that once the machine can understand, machines will not have emotions into that. They will understand it very, if they are trained well, they will understand it or they will not understand it. So, to improve that accuracy, that they understand it better and better, your challenges are many, right. So, you have to train them better. Some of the most significant challenges are sarcasm, negations, context dependency and domain specificity, right. Now, sarcasm is, for example, you see one of the biggest challenges in sentiment analysis, because it often conveys a meaning opposite to the literal interpretation of the words. So, sentiment analysis models typically rely on words and their associated sentiment scores, but sarcasm remarks can mislead these models. So, oh, you look great today, I think you should have not wore this dress. Now, actually I am confusing someone because I am creating a sarcasm. I am trying to say that you are not looking good on this dress, but here I am saying, oh, you are looking great today. So, this is a sarcasm, right. Why is sarcasm difficult to detect? If often includes positive words used in a negative sense, right. It depends on the tone, context and prior knowledge, which text based models struggle to grasp. Obviously, how will the machine understand that? Humans rely on the intonation, right, the way you say, the facial expressions or the context clues which are absent in the plain text. So, for example, when we humans do lot of non-verbal communication also, but how does a machine understand that non-verbal communication? So, there is a lot to work upon this kind of subject, because there will be a day when man will try to make the machine a better replica of it. So, as humans can understand, we would like that machines also do understand, so that our work is easier. But how do we do that? Suppose words are fine, words at least you can train them. What about those intonations? What about those expressions? How will the machine understand it? So, maybe you can feed in such kind of expressions also, and maybe the machine models will improve with time slowly, right. Example you see here, oh great, another delay. Now, it is saying, so great is a good word, positive word, but another delay. So, he is a sarcasm, making a sarcasm, right. A basic sentiment analysis model may consider great as positive and conclude that this sentence is positive, but actual sentiment is about expressing frustration, so implying dissatisfaction. How can we address sarcasm in sentiment analysis? So, to address sarcasm in sentiment analysis, use context aware models like transformers, example BERT, GPT, right, that analyze preceding and following sentences. So, what it is doing? It is analyzing your preceding and following sentences. Incorporate sentiment shift detection techniques, right. So, how is the sentiment shifting, right? Trains models on the sarcasm labeled datasets to recognize common sarcasms or sarcastic patterns. Okay. So, this by doing such kind of improvements slowly, little and little and little, the machine is trained better. So, the improvement of the model will be higher, right, and the machine's accuracy levels also will be more in comparison when you have not trained the models better, right. Negations can reverse the sentiment of a sentence. Traditional sentiment analysis models often assign sentiment scores to individual words, but may fail to detect the effect of negation. Words like not, never or barely. Why is it difficult? A word that is normally positive or negative changes meaning when negated. Simple keyword based approaches fail to capture negation correctly, right. So, the scope of negation is crucial, but does it apply to one word or the entire sentence is a question, right. So, let us see this. Without negation, I like this movie, positive sentiment. With negation, I do not like this movie, negative sentiment, right. A simple model might detect like and classify the sentence as positive, ignoring don't, right. So, for example, when we had said you might if it ignores the word don't, then it will become a I like this movie, which is a positive sentiment, but actually it is a reverse. How can we handle negation? Use dependency parsing to determine relationships between the words, right. Train models to understand negation patterns and implement rule based approaches. Example, tagging negation words and modifying sentiments scores accordingly, right. So, you see all this needs extreme high level of training, right. Then context dependency, words have different meanings based on the surrounding context. A sentiment analysis model relies relies only on word level sentiment score may misinterpret such words, because you see why many words have multiple meanings, which is called polysemy, right. Same word, multiple meaning, right. The same word can express different sentiments. In English, we have seen certain words giving you different meanings, right, at different places, right. So, same word can express different sentiments depending on the context. Idioms, phrases and slangs require deeper understanding. Okay. You see this example. Sentence 1, it says he was mad at his boss. Negative sentiment. Mad means angry, right. The party was mad fun. Sentence 2. Now, here the same mad means very or extremely. So, fun, which is a positive sentiment, right. Now, because of the use of the word in different contexts has given different meanings. Now, it is becoming complex, right. A simple model may classify both sentences in negative because it associates mad with anger, but however, in the second one it is creating a positive sentiment, right. Now, how to improve this kind of context handling? Use word embeddings. So, we have also discussed in the earlier classes word to vector, globe vector, right. So, that considers word relationships. So, you uses lot of grammar and dictionary, right. So, use context aware models like BERT, which analyzes the entire sentence and trains models on large diverse data sets to capture the different usages. The last is domain specificity. Words can carry different sentiments in different domains. A model trained on one domain may misinterpret the sentiment in another. Now, why is it so difficult? Or why is domain specificity a problem? You see, the same word can be positive in one domain and negative in another, right. General assignment sentiment models fail to adopt to domain specific language. Slang, jargon, technical terms will vary across fields. Let us see sentence 1. It says, now this is a automobile domain, right. This car's handling is unpredictable. This car's handling is unpredictable. It is a negative, right, because unpredictability is bad for a car, isn't it? Now, second one, the movie review. Now, same word now will in a movie review. Now, what will happen? This thriller has an unpredictable plot. Now, how do you see a thriller with an unpredictable plot? Obviously, it is great, right? So, positive. Unpredictability makes the movie more exciting. Okay. So, with two different domains, automobile and movie, the same word unpredictable has created different interpretations. So, a generic sentiment analysis may not differentiate between the two cases, leading to incorrect classification. So, how do you handle such a problem? Now, train the separate models for different domains and use transfer learning. Start with a general sentiment model and fine tune it on domain specific data. So, with time, better models will improve, will come, and they will be done on basis of domain specific. So, the scope of this kind of text analysis is immense and huge, right? So, it is just the tip of the iceberg. We have not even entered into it. There is lot of ways you can use such kind of data. So, implement domain adaptation techniques to just adjust sentiment scores based on the context. Okay. So, what are the techniques for the sentiment analysis? So, various techniques are used ranging from simple rule based approaches to advanced deep learning methods. So, for example, we have rule based methods, machine learning based approaches, and deep learning and transformer based models. Okay. So, what are rule based models? Rule based sentiment analysis relies on predefined linguistic rules to determine the sentiment. So, these rules are often created using lexicons or sentiment dictionaries. So, collection of words with assigned sentiment scores like happy is equal to positive, sad is equal to negative, right? Grammar rules to handle negations. So, example, not good is negative despite containing the word good. Okay. Part of speech tagging, identifying adjectives, verbs and nouns that contribute to sentiment. Example, exciting indicates a positive sentiment. Okay. A rule based system may analyze the sentence, the movie was excellent. The word excellent is found in a sentiment lexicon with a strong positive score, right? The sentence is classified as positive. The movie was not excellent. The word not negates the positive sentiment of excellent. The sentence is classified as negative. Right? So, what it is saying? The movie was excellent, the movie was not excellent. So, because of the word not, now it is giving a negative, right. So, importance is it is simple and interpretable and does not require too much of label trained data and works well for specific domains, right, where sentiment words are well defined. But limitations are again it struggles with sarcasm, slang and new words and requires manual tuning of rules for different data sets. Then you have this machine learning based approaches. Now, machine learning based approaches, we have the process involves feature extraction, model training, prediction. Now, what is feature extraction? Transforming text into numerical data using techniques like bag of words, which we have already done, right. So, or term frequency inverse document frequency, right. So, we have also learned how to calculate that. Then you have model training a classifier, example like naive Bayes support vector machines on labeled sentiment data, right. Or the third one is applying the trained model to new text to classify its sentiment, to see how the trained model now is helping to classify the sentiment in a new text. So, this will help you to predict the accuracy of the model. Okay. You see the example. So, consider training a model using movie reviews based on positive or negative. So, the data set is the movie was fantastic, positive. It was a terrible film, negative. Once trained, the model can classify new reviews. So, new review, the film was wonderful. The model recognizes wonderful, right, as a positive feature. It classifies the review as positive, right. Importance, more flexible than rule based methods, can adapt to different domains by training or domain specific data and handles variations in sentence structure better. Okay. It requires a large data set for training and cannot easily handle out of vocabulary words or slang unless retrained. So, it has to be constantly trained, right, otherwise it will not work. The last one is the deep learning and transformer based models. Okay. Now, deep learning models, particularly the transformer models, are capable of capturing intricate patterns in text. So, that is where now the higher training or higher learning is coming into place. So, these models use neural networks, right, especially recurrent neural networks RNNs, and long short term memory LSTM networks, and transformer models like BERT and GPT. What is the advantage? It understands relationships, word relationships, contexts, which is more difficult for generally, right? Captures sentiments even in complex and nuanced sentences, and handles sarcasm, double negatives, and contextual variations better than the traditional approaches. You see the example. I expected more from the review, but it was just okay. So, a traditional machine learning model might struggle to classify this because okay is neutral, but expected more suggests disappointment. A transformer based model like BERT, bidirectional encoder representations from transformers, can understand the underlying sentiment by analyzing the entire sentence contextually. Okay. So, what is the importance? State of the art accuracy, works well for customer feedback, social media sentiment analysis, and chatbots, and can handle large scale data efficiently. But the limitations are also there, like anything that is good has also some limitations. Very high computational power it requires, and needs large data sets for training to get more accurate models, and be complex to interpret, right? So, these are the challenges that you have. But anyway, we have understood today that sentiment analysis has a lot of role to play, and as we discussed, there is a lot of scope for improvement, and with the use of such kind of techniques, with better accuracy models, right, companies and researchers can use for a large amount of research purpose and better understanding of customers, their needs, all these things, right. So, it helps a lot, right. So, I hope sentiment analysis is clear to you. So, we will go with some of the approach of going into the next other techniques also in the coming lecture. We may also do some of the hands on experience we are training, right. I will show you how to conduct some of these techniques, so that it becomes easier for you to work when you are doing on your own, right. So, till then I will wind up here. Till then, take care. Thank you very much. So, meet you in the next lecture. Thank you.